Text tonality classification using a hybrid convolutional neural network with parallel and sequential connections between layers. The analysis of the tonality of text is an urgent problem in the field of natural language processing, which is often solved with the help of convolutional neural networks. However, most of these CNN models focus only on the study of local functions, ignoring global features. In this paper, a hybrid convolutional neural network with parallel sequential connections is proposed for the analyzing of text tonality. The proposed hybrid convolutional neural network extracts text features using a parallel connected convolutional block. Then the neural network classifies the features and combines these features with the original text features. Text classification is widely used in tonal analysis, stock market analysis, and for automated email responses. Methods based on in-depth learning of neural networks have become current practice along with classical algorithms for text mining. Document classification is a process of assigning documents to a certain category depending on their content. Text classification is necessary to solve the following tasks: personification in advertising, sites division by the thematic catalogs, fighting against deceptive or misleading advertising correspondence, and text tone recognition. The aim of this work is to develop a new model of the architecture of a convolutional neural network with parallel and sequential connections between layers to classify the tonality of text with increased efficiency. The problem of classification of textual information is formulated as follows. Let there be a finite number of classes in category and a finite set of documents, and unknown target function f, which determines the correspondence for each pair, document and class. The task is to find function f0, which is as close as possible to the objective function f, that is, a minimum rate is provided in Euclidean space. Function f0 is called a classifier. Text tonality is understood as the emotional vocabulary and emotional assignment given by the author in relation to the object. The analysis of the text tonality is of great practical importance. Quality evaluation of goods and services based on users' feedback of internet resources, prevention of extremism and terrorism, and analysis of stock market and forecasting the variability of financial assets. The main task of text tonality analysis is to identify ideas in the text and determine their properties. Opinions are of two types: opinion comparison and direct opinion. Direct opinion contains the author's statement about the object. The formal opinion definition is described as a tuple of four elements: orientational or polar assessment of tonality, entity object or future object of tonality and their properties, the time when the opinion was sent, and the subject of tonality. The architecture of a new hybrid convolutional network consists of a convolutional neural network block with parallel and serial connection between layers and a maximum pooling layer which is obtained from the matrix of the original text. You can use different cores to convolve a sentence and to obtain different features in the proposed convolutional neural network. The mined features are combined with the matrix of maximum pooling obtained from x0 with the help of a convolutional neural network block. These features are classified using MLP classifier. The text is entered as the input of the branched convolutional network. This neural network consists of two parts: a block of convolutional neural network with parallel and sequential connections between layers and a maximum pooling layer. The block of the convolutional neural network consists of layers with different window sizes, which are connected in parallel along the columns and sequentially along the rows of the structure. The input of each convolutional layer in the column consists of the sum of the outputs of all previous layers. A parallel text matrix is applied at the entrance of convoluted layers with dimensions 5D, 4D, 3D, and 2D. To classify the text tonality, we will use the average general features, which can be obtained by combining the two characteristics. Feature obtained from the convolutional neural block He1 and from the maximum pooling layer He2 due to the global average. Each convolutional subnet is used to mine features using different word combination depending on the size of the kernels. In particular, for the kernel 5D, a combination of 5 words is used to mine the features. Similarly, the input text matrix is presented based a subnet with kernels 2D, 3D, and 4D. Input text matrix X0 is introduced into convoluted layers of size 5D, 4D, 3D, and 2D to mine features. After that, the initial input text matrix is combined with the future matrices after the convolutional transformation, and we obtain new input text matrices. We introduce new input text matrices into the second convolutional layers with kernels 5D, 4D, 3D, and 2D. To obtain new future matrices, we perform the following operation to combine matrices. After convolutional transformation, a pooling operation is performed to obtain new future matrices. After that, the new future matrices are combined to obtain a matrix of a multi-scale block for mining convolutional features. The cat function describes the merging of matrices. The future matrix from the maximum pool layer of dimension 50 is described by the formula. We combine matrix future He1 and He2 using function cat to obtain a general future matrix He, and perform one-dimensional global averaging operation to obtain a final future matrix. Function G is a one-dimensional average measure. After that, we present the final future matrix to the neural network classifier to classify the text tonality. In computer experiment, 6 different data sets were selected for the computer experiment, which are divided into different categories of text tonality. They include game multi-tweet, SAM Evol, SS Tweet, AG News, R8, and Yahoo Answers datasets. All of these datasets were randomly divided into 3 parts: 70% training set, 15% validation set, and 15% testing set. You can see information about dataset in this table. Our model is compared with other models, CNN, TextCNN, FastText, and DPCNN models. Findings presented in this table show that our model has achieved higher accuracy than its counterparts, that we can see in this table. In conclusion, A hybrid convolutional neural network for text tonality analysis has been developed. It consists a convolutional block of a parallel and sequential connection between layers, and a layer for a maximum polling obtained from the matrix of the original text. It is shown that such a hybrid convolutional neural network mines text features using a convolutional block. Then it mines and classifies the features by combining this feature with the original textual feature. It was proved that a hybrid convolutional neural network with a parallel and sequential connection between layers provided higher efficiency of text tonality classification in 6 different databases. Thank you for your attention.